Today, I'm going to talk about the built-in function. There are numerous built-in functions in MATLAB. The MATLAB has already coded many basic functions. This lecture is to introduce some key built-in functions and their usage or syntaxes. More importantly, in these lectures, I would like to highlight how the operation or functionality of the built-in functions can be achieved using matrix operations or the selection and the loop statement. At the end of these lectures, you can use array as an input argument of the built-in function. To print elements in variables and format the output text. You can apply the built-in arithmetic functions and replicate the same functionality of the built-in function using the selection and loop statement. Finally, use a sort function to sort the array element in ascending or descending order. So while we use the built-in function, the basic operation is already coded in function inside, and it supports the various input type. This is important. This means the built-in function supports array, not single scalar, as an input for the function. For example, if you put the 2D matrix in the round function, round operation is performed in each element in the input array. Let's see the example. Okay, let's think about how to write a code to round to the nearest integer of each value in the vector. If you see this phrase of each values in vector, you have to recall the loop statement right away. And the action is round to the nearest integer. That is the round built-in function, right? So we can write a script to perform this operation using a loop statement like this. Okay, first to count the number of elements and initialize your output vector, and then set up the loop range 1 to n vector, and then putting the single scalar element to the round function, and then output value assigned to that vector r. However, since the built-in functions support array type, the shown in the previous slide, like here, vector, matrix, so we can simply put this array into the function. Then you will get the same outcome. So like this. You can just simply put the vector in the round function, then you will get the same outcome. Okay. In this case, the input and output dimension are same. So vector r is the same dimension. So we don't need to find out the number of elements or this loop structure to get the vector r value. Okay. So remember that the point is entire array, vectors or matrices can be used as input argument to the function if the function supports those input. You can check this information in the the MATLAB document. So there is an input argument section, and then check the possible input array input type. So this is a very powerful feature, right? So this whole script is shortened by in one single line, right? Let's solve the similar problem. How to compute the square root of each value in the vector. Okay, so you can read the description and how what is the function is, and then here that as the input is a link to this document. You can click that, you can see that input argument x input support the scalar, vector, and matrix, right? So in this case, you can read the individual value, okay, using the for loop, and then apply the square root function here, or you can directly put this vector as an input for the square function. Okay, but you know, I think that all the basic operation, the function for basic operation support the array type. But every time you use those function, you need to check that the function support array as an input. Okay. Second question is how to write a code to compute the sign of each value in a matrix. Okay. If you're solving this problem using the loop structure, you first find out the size of your matrix, and then design the double loop structure to read each value using the subscript indexing, like this. Then apply the disassign built-in function, and resulting value is to assign to the corresponding location. Okay. But another way is the MATLAB doc sign. MATLAB support the assign built-in function support the vectors and matrix as an input. Okay, so if you directly put this matrix and sign function, you will get the the signs of the each value. Okay. Can you see my point? Okay, let's do the simple experiment. Okay. Yeah. So mat1 2 3 2 4 -1 -2 4 0 3 0 -1. mat1 is like this. Sign mat1, you get this one. Okay. Yeah, I'm going to introduce some array operation built-in function. Some of them were already introduced in the previous lectures or the tutorial. Okay. Reshape. Reshape is to change the size of the array of vector. You can reshape or change the size of the array if the number of elements in A and B should be the same. So this size is number of element in this size should be the same with number of elements in A. So in this case, vector is the 1 by 12 row vector. So you can reshape with the 2 by 6, shapes 3 by 4, or even the 6 by 2. But the placement of value is in a linear indexing order. Okay. Indexing order. Okay, select this one, right? Oh, this one. Okay. The flip is to reverse the order of element in A, the input matrix, along the dimension. The flip does the different operations depending on this second argument, dimension argument. 1 is indicating the vertical direction, 2 indicating the horizontal direction. Okay, so basically this dim of the input argument is very common, very important, because this syntax is frequently used in the MATLAB. Okay, when you review the documents, the MATLAB document, if a dimension is accepted as an input argument, 1 is always vertical direction, 2 is horizontal direction. If the function supports the 3, 3 is the depth dimension. Okay? Basically, if you set the 1, we do this operation, whatever operation is, in the road is a vertical direction. Okay? For instance, in here, flip mat 0 and 1. Here's the mat 0. If you set the 1, they do flip in the vertical direction. So this one goes up, this one goes down. So you will get this matrix. What about the mat 0 and 2nd? They perform this horizontal direction. So that's why this goes to here, this goes to here, this goes to here, this goes to here. So you will get this matrix. Oh, sorry. This is not true. This is the mat 1, right? So this one goes to here, this one goes to here. Okay, so let me erase this. This goes to here, this goes to here, this goes to here, this goes to here. So you get this matrix. Okay, makes sense? What is the function that do the same operation of this one? Flip LR, right? LR means left to the right. This is like a horizontal direction. So what about this one? Flip UD, up and down. Okay? So CAT is abbreviations of the concatenating. The CAT is to concatenate the array along the dimension specified in the input argument. We have learned the concatenation in the horizontal direction. So like how to join the mat 0 and mat 1 in the horizontal direction. You just place this variable inside of the square bracket without with the empty space or the comma. This is how we create the row vector, right? How to join them in a vertical direction? You can mat 0. You can separate them using this semicolon, right? So we can do the same operation using the cat built-in function. Let's say mat 0 and mat 1, and then set up the 1. What is the 1 direction? It's a vertical. That's why mat 2 is this one. This is the same mat 0, mat 1. Okay. What about the mat 3? Mat 3 is the 2 is the horizontal direction, and you'll get this matrix that is the same mat 1. Okay? But if we use the 3, that is the depth direction. This is the depth direction. So you will get this 3D matrix is 2 by 2 by 2. So actually the cat function is useful for joining the multiple matrix or joining the matrix in depth, because there's no matrices like a syntax to join. So in the horizontal direction is a vertical direction, you have this syntax, right? But in the depth direction there's no such syntax. So this cat built-in function is useful in that sense. Okay? Diag is to read the diagonal value in a matrix or make a matrix having a given diagonal element. Okay? If the vector is an input, if the vector it return the square diagonal matrix D of which elements diagonal elements is V. If you're putting in the matrix in diagonal function and return a column vector of the main diagonal element of the matrix A. Okay, so let's see this example. Mat 0 is this 3 by 3 matrix, and V is a column vector. Okay, if you plug, so okay, the not V is this one. So I mean the V vector is the 1 by 3 row vector. If you plug in the vector in the diagonal, you'll get this D matrix, and its diagonal element is the same with the 1, 2, 3. Okay, if you plug in the matrix, you will get this element. Yes. So get this column vector. Okay, how can you implement this diagonal built-in function using the loop statement, loop and if statement? That's easy, right? Let's say if you're going to make this diagonal matrix, you first initialize with the 3 by 3, so I'll say the 0 vector, a 0 matrix, and then we are accessing the those location. Okay, how? We can just one single loop structure, because the index for row and then columns are same. So referring this position in the D matrix and then plug in those values to here. Okay? In this case, you don't have to design the double loop structure. The reason I am telling this one is I saw the many cases that students write this, this script. Let's say vector is 1, 2, 3, and then D is 0. For II is equal to 1, 2, 3. So let's say if you print D and clear, if you run it, you will get this square matrix, right? All 0 except for diagonal element. But some students, write this script using the double loop. I saw many cases, okay? Like one design the double loop and then use the selection statement. II is equal to JJ, and then DII JJ is the vector II. I think that this is also the correct script, but designing the double loop structure in this question is unnecessary. Okay. So output functions are to print out the numeric or character value in the variable. The ISP and the fprintf are two basic output functions in general, but I usually use the fprintf because I can format the text output. The format spec is the character vectors including the formatting identifiers. Then you can place the value of the variable in A1 and A2 and A3, so on, to insert their values in the place of these identifiers. You'll see how to use this syntax in the later slide. Before then, when you print out the multiple lines, you need to put this this these are characters at the end of the format spec. Okay, let's see this example. The ISP to simply print out the value inside your variable and then value itself. So if you put the X, so this display this a value, then the ISP and then V, you can also print out the value in the vector or the matrix, or you can print out the character vector. So here I said the print out means you can print out the text in your command window. Okay, here's the fprintf. This is just a plain the character vector, but this is the identifier. Okay, if you place identifier, you need to place a corresponding value after comma. So this means, so you're going to put this the character, so you put the character here, so you can plug in this character here, so you get the same. You print out the same message. So here S is the like a character vector, so you can plug in this character vector here. And if this format spec or format spec character vectors include this one, this is comments like a new line, so you'll print out like this. Okay, and in this case, if you want to print out the numeric value, you're going to use the %f %d. D is the integer, f is the float. I mean the double procedure. F is the real number. Okay, so we will revisit this topic in the text manipulation later. Okay, I'm going to show the brief example. Let's say here define some sequence Excel, MS Excel. S2 is the MATLAB, like a year 2, like this, and then print f hello. So character vectors, and then year 1, year, then like this, S1 and Y1. Can copy this. Okay, let's print out the new line like this. Okay, then okay, if you run it, I put print tab, right? Print app, then run it. You can print out this one. Okay. So do you understand how to use that? So you can place the identifier and then put the value after comma. Okay, that is corresponding to this A1 and A2 here. Okay, in S1 is if you include this identifier, you need to place the value here. Okay, so I'm going to teach these 5 basic and important arithmetic operation function. We will also learn how to replicate the sum of these function using selection and the loop statement. Okay, the sum function. Some function is to some values in your variable. If A is a matrix, then sum A return a row vector containing the sum of each column. Okay? As sum A dimension, return the sum along the dimension. Okay, so what is this one? This one is the same with the sum A first dimension, because they're the summation of the value in each column, right? It's like a vertical direction. Okay, so if you put the A when the A is a matrix, that is the same with the sum A1. Like a default of the second value is a 1 in this case. Do you get this point? Okay, let's see the example. So mat 0 is a 3 by 3 matrix. Vector is a 1 by 3 row vector. So sum vac is the summation of all these elements. That is a 6, right? Okay. What about the summation of the mat 0? I'll say it should be conducted in the vertical direction, right? That because that is the first dimension, so you'll get 8, 9, 9. So get this a row vector. That is this one and this one, because the default dimension is a 1 in this case. Okay. How about the vector 2? When you set up the second dimension, that is conducted in the horizontal direction. Okay, this one is 5, not 5, 6, 11, 9. So you get vector 2. Okay. The last syntax is all. This is which is adding all elements in a given matrix. When I used the older versions of the MATLAB, there was no such a syntax. This all syntax. So why? Why MATLAB did not, make this option? Because it looks, useful, right? But why MATLAB did not make this this one, summing up the all element? Because we can easily replicate that. Okay, how we can replicate this one? You can just simply sum this one. Okay, what is this? Using the linear indexing, we can read the all value. So this one, let's say mat 0, this return is like a flatten all this is like a value in the matrix. You will get 2, 4, 2, 1 like this. So this one is we plug in this vector to here. That's why we are following this syntax. Get summing up the all value. That's why we get this same value. Make sense? Okay, so here's the example. These both the script are producing the same value. Here's the mean. Mean is to do mean average of element in matrix or the vector. Okay, the syntax structure is exactly same except for it's a basic operation. Okay? Syntax are same. The previous one is that we are do the summation. Here is you do the averaging. Okay. So let's take a look at only this one. Vector, you plug in the vector Average is 6 divided by the 3 is 2, right? What about this one? Met 0 is this one. Averaging in the vertical direction, so you get this one. Makes sense? It's very straightforward. If you understand this basic syntax, you can easily use this function. Only difference is operation, mean operation or summation operation. Here, we do sum and mean operations using built-in function. Now we know how to use the sum and mean function. How we can replicate this same functionality, this is a very important. You replicate the same functionality in the built-in function using the loop statement, because that is a basic of the programming. Okay, here's the function with the built-in function. Okay, how we can get this? How we can get this a vector 1 and vector 2 s1 s2 using loop statement. That is this script. Okay, let's see the one by one. Sum at 0 in the second dimension is a summation of the value in the row direction, in the horizontal direction. Okay, so and also vector 2 is the S1 is the summation of the all value, right? So let's see this script. First, we find out the numbers of the row, numbers of the column, and then S1 and vector 1. This one is initialized. S1 is a single scalar, and vector 1 is what is the final size of the vector 1? We are summation of in the horizontal direction, so you will get 3 by 1, that is nr by 1. So that's why nr by 1. So we design the double loop structure. S1 is we are summing up the all value. So we are taking this structure, reading the value, adding to the S1. And vector 1 is we are adding this value to the corresponding locations, because II is indicating the row and ZZ is indicating the column. So this one is basically we are adding all the value in the same row in the vector 1. Okay. And then now, how we can find the mean value? This is the mean value, this one. So mean of this one is we are just dividing by numbers of the column, right? We are adding this value, and this value. So mean of each value, so we just divide by the NC, numbers of the column. Okay? But here we don't need to write script like this. Okay? Both are same when the scalar is involved. Okay? How about the mean of the all value? You can divide by the numbers of the all element. That is nr times nc. Make sense? Okay. The median is like a middle value of the element A, input matrix or input vector. So median is the middle number after sorting the element. Okay. Again, the syntax structure is exactly same as the mean or the sum function. Okay. Again, the only difference is each operation. Okay. For instance, here, let's say, what is the middle value of the 1, 2, 3? That is a 2, right? Okay, what is the middle value of this one? 2, 2, 4, that is this one. Okay? Because we just picked the middle value. It's not an average. Okay? What is the middle value? That is the 3. That is the 3 as well. So get this one. Okay? What about the middle value of this one? It's like a even number element. That is, after sorting it, you pick the the middle value of the adjacency, the middle element. So this become a 3. Okay. So can you replicate this function using a loop and then selection statement? Not yet, because it requires to know how to sort the value so that we can pick the middle value. Okay, so we'll learn about how to sorting the element.